Right now, our planet runs on an immense, continuous stream of fusion energy. Every wind current, every ocean wave, and every single living cell is ultimately powered by a massive, burning sphere of plasma 93 million miles away. But imagine if that power supply were cut off. What if the sun completely vanished from the center of the solar system this very second? In the exact millisecond the sun disappears, absolutely nothing would change here on Earth. You wouldn't notice a thing. The sudden loss of our star wouldn't cause immediate chaos because the physics of our universe operates under a strict cosmic speed limit. This diagram shows the inner solar system. The sun's light travels at 186,000 miles per second. It takes 8 minutes and 20 seconds for this final wave of light to cross the vast distance to Earth. Down on the surface, life carries on normally. People keep walking, birds keep flying, and solar panels keep drawing power, completely oblivious that they are soaking up light from a star that no longer exists. Gravity operates under the same constraint, traveling at exactly the same speed as light. Earth's orbit remains temporarily unaffected, curving obediently around an empty point in space as those final gravitational waves complete their journey. For over 8 minutes, all of humanity lives on borrowed time, unaware that our cosmic anchor is already gone. Then the countdown hits 0. The daytime sky abruptly extinguishes, replacing the familiar blue atmosphere with a pitch-black, star-filled void. At that exact moment, the final gravitational wave passes by. Earth loses its tether and stops curving. The planet snaps into a straight-line trajectory, launching directly out into interstellar space. You might expect the planet to instantly freeze into a solid ball of ice the second the light vanishes. However, that violates the laws of thermodynamics. Earth's atmosphere and its vast oceans act as massive thermal batteries. Having absorbed incredible amounts of solar radiation over time, they slowly release that stored heat back into the environment, keeping surface temperatures relatively stable in the immediate aftermath. The biological impact is instantaneous. Photosynthesis completely stops across the globe, cutting off the foundational energy source for the entire planetary food chain. Within the first 24 hours, humanity's survival instinct kicks in. Cities pivot entirely to artificial lighting and stored energy grids. Transportation and communication networks continue humming, but the drain on our energy reserves accelerates by the hour. Fast forward a few weeks, and those thermal batteries start running empty. Surface temperatures plummet. Vegetation dies off in the perpetual night, and terrestrial ecosystems quickly collapse. Look at this cross-section of the ocean. As the surface water freezes, it creates a thick top layer of ice. This ice actually acts as a thermal blanket, insulating the massive volume of liquid water and trapped heat directly underneath it. Down in the absolute darkness of the ocean floor, marine life continues largely uninterrupted. Entire ecosystems thrive around hydrothermal vents, feeding on chemical energy bubbling up from the Earth's crust. A few years later, the terrestrial surface is a wasteland. The topsoil is frozen solid. The atmosphere cools so much that gases begin falling to the ground as snow. Yet, humanity's story wouldn't necessarily be over. We would have one massive power source remaining, geothermal energy radiating outward from Earth's molten core. Deep underground, in massive excavated caverns, human habitats could theoretically survive. These settlements would rely on geothermal vents to provide heat and generate electricity for vast banks of artificial grow lights. Even as a rogue ice planet drifting blindly through the interstellar void, Earth holds enough internal heat to sustain isolated pockets of life. Our planet is far more resilient than its fragile surface suggests. Decades into this long journey, Earth exists as a tiny, dark, rogue planet drifting silently through the galaxy. While a fraction of biological life might cling to survival in those deep underground bunkers, the vibrant, interconnected world as we know it would be erased. But we don't live on a rogue planet. Outside your window right now, the morning sky is bright. The air is warm, and a standard, normal day is well underway. The sun provides the physical energy to drive our weather patterns, fuel massive ocean currents, and power every biological system. Every ordinary sunrise is a reminder that Earth does not exist in isolation. We thrive entirely because of a delicate and incredibly lucky cosmic relationship with our star.